Hello and welcome to the Acceleration in an Elevator video tutorial. We got a man and his cargo riding in an elevator, and that elevator is accelerating up. We're going to see if we can determine the tension in this cable here and the apparent weight of the man. The weight of the man is 960 newtons. Apparent weight is what his weight feels like because he's accelerating. It's that idea that if you're in an elevator, in this case accelerating up, your knees feel that kind of compression, like you're being smashed into the floor, so you feel like you weigh more during that time. So when we solve for part B, we should be getting an answer larger than 960 because we feel like we weigh more at that time. All right. The secret to solving these problems, both of them, is about defining the system. So we're going to start by just doing that. So let's put a box around our system. For problem 1, the whole thing is the system, and there, it's back. There you go, a little dash box to show what the system is. So everything is the system, because that's what the rope is pulling on. The rope is pulling up all this stuff. So we're going to start by doing a free body diagram for our system. Let's get an arrow here. So we've got the cable pulling up on everything, and we've got the earth pulling down on everything. So this one up here, that's the cable, is FT. And this down here is the planet, so that is FG. Alright, so there's, actually let's fix this arrow really quick so we can actually see the object. So there it is. So now we've got our object here in the middle. So rope pulling up, gravity pulling down. So let's create a force equation from our free body diagram. So our up force is the force of tension, and our down force is the force of gravity. And if this object here was not accelerating, then this would equal 0, but it is accelerating. It says so in the problem, so that's going to be equal to mass times acceleration. All right, the force of tension is unknown, and the force of gravity, the force of gravity is, well, this is the man, that's the crates, and that's the elevator, so all that put together. So let's do this really quick. 960 plus 1600 plus 5000 is 7560. We do not need to multiply by 9.8 because these are already weights. They're in newtons, that's weight. All right, mass is the weight divided by 9.8, so there's our weight right there. So let's just divide that by 9.8, and that gives you 771.43. And the acceleration is 0.6. It's going to be a positive 0.6 because we are accelerating up. All right. The force of tension is equal to, well, multiply these together and then add the 7560. So 771.43 times 0.6 plus 7560 gives 8,022.86 newtons. So there's your force of tension, this thing pulling up. This makes sense as an answer because if the elevator was not moving, it was just sitting there, then this would be the answer, 7650. But because it's accelerating up, this rope has to work a little extra hard on the system, so that's why the force is a little bit more. All right, now we're going to do part B. Part B, oh, before we move on to part B, if FG is 7560 and FT is 8022.86, this number is larger. This arrow should be larger. So we can correct that by just making that arrow a little bit smaller. So FT should be larger than FG. All right, now on to the second part. All we're going to do is change the system. So now the system isn't all that stuff. We could care less about the rope. We just care about the guy. We don't care about the crates either. We want the apparent weight of the man. So here's our new system right here. And actually, everything stays pretty close to the same. But the rope is not pulling him up. It is the floor that is pulling him up. or pushing on him upward. So that's Fn, the normal force from the floor. Earth is pulling down on the guy, and because he is accelerating up, we would expect this arrow to be larger than that arrow, so that the net force is positive. So actually that's all that changes, is an Ft changes to an Fn. So we have Fn, because that's our up force, minus Fg, because that's our down force, and this looks a lot like what we just did. Almost identical, is equal to ma, because he is accelerating. Right. So Fn is the unknown. That's going to be his apparent weight, because that's what, if you were to put a scale right below his feet, that's what the scale would read, is this right here, the Fn. So it's giving what his weight feels like. His Fg is 960, says so in the problem. His mass is just 960 divided by 9.8, so 97.96, and the acceleration is 0.6. So Fn is equal to, well, multiply these together and then add the 960. So 97.96 times 0.6 plus 960 gives 1018.78. Now before we started the problem, we said that we would expect an answer larger than 960 because he feels that compression in his knees. And sure enough, here it is. 1018 is larger than 960, so our answer makes sense. So that's a good answer. If the elevator was accelerating downward, he would feel lighter, and so we would expect the apparent weight to go down. So we'd expect this answer to be less than 960, and the way you would get that result is that this number would be negative. So you'd be having a negative value here added to the 960, so it would actually make the 960 less, and you would get a smaller answer if he was accelerating down. Thank you for watching the Acceleration in an Elevator video tutorial.